In this video, I talk about some concepts relating to electromagnetic induction which appear in an undergraduate Introduction to Physics curriculum. So let us start with what is an electromotive force, written as EMF, or sometimes it's also referred to as the voltage. EMF is the electrical action produced by a non-electrical source. This is interesting. So we are able to produce some sort of electrical phenomena in an object by doing something that is not related to electricity. For example, we could be moving an object, rotating an object, and that produces some sort of electrical current or electric behavior inside that object, and this behavior is produced because EMF gets produced or induced in the object, and this entire thing is called electromagnetic induction. So for example, a commonly used battery source is converting chemical energy into electrical energy. So battery is a source of EMF, and there could be other sources of EMF depending on if it's doing this production of current because of chemical reaction or because of physical motion. Then we define what is electromagnetic induction. It is the production of EMF across an electrical conductor due to changing magnetic field. So whenever we have a conductor which is present in a region, and if the conductor experiences a change in magnetic field, and this magnetic field could be created by a different source, like a permanent magnet in its neighborhood, then the conductor will have some sort of current produced inside it, and this current is called an induced current. It is reported that Faraday, along with a few other scientists, observed the induced current to be produced in a coil when the magnetic field passing through the coil was changing with time. And so this became an important discovery, that we were able to produce current in a coil by changing the magnetic field through the coil. And this magnetic field was produced by some magnets which were present near the coil. And essentially that is the principle using which we still produce electricity to this day. To understand how electricity or current is induced in a conductor because of changing magnetic field, we will start with defining motional EMF. So what does motional EMF mean? Essentially, the idea is that the motion of a conductor through a magnetic field can induce voltage, and this induced voltage can in return produce current in that conductor. Now, why does this induce EMF or induced current? Let us look at what happens to the charges which are present inside the conductor. We all know that every material has charges, both positive and negative, and the thing with conductors is that the charges are free to move inside a conductor on application of small voltages, and we will see how this motional EMF brings about moving these charges. So let's see that a charge Q is moving with some velocity v, and the charge is Q, and it is moving with some velocity v in an external magnetic field produced by some sort of a magnet, and such charge will experience Lorentz force. And we have seen this before. And the Lorentz force is given by this formula, where theta is the angle between the velocity vector of the charge and the field which is present in the surrounding region of the charge. So once the Lorentz field starts acting on the charge, the Lorentz force is going to push opposite charges in opposite directions inside the conductor. That means positive charges get pushed towards one end and the negative charges get pushed towards the opposite end of the conductor. And so when this charge separation occurs inside a conductor, essentially we say that a voltage is produced in the conductor. That's how the EMF gets induced, because of a Lorentz force acting on opposite charges inside a neutral conductor. This all happens because the conductor is moving in a magnetic field. Now, whenever the theta between the velocity vector and the field vector is 90 degrees, then the EMF can be obtained using this simple formula. We are not deriving how this comes from. That's not the purpose of this video, but we're going to say that we can now use this equation to calculate the voltage or the motional EMF produced in a moving conductor. So this is a neutral conductor which is moving inside a field B, and because it's moving, we just call it motional EMF. Let's take an example of studying and the motional EMF concept and applying it for calculating the voltage generated across a long wire. So in this problem, we are asked to calculate the induced voltage or the motional EMF, which is present in or across a 20 kilometer long wire. So this is a straight wire which is 20 kilometers long. It's a very long wire, and it's in the outer space, and it's moving at a very high speed of 7.8 kilometers per second. And essentially, as you see in the picture, this wire is essentially holding this satellite to a space shuttle. So this is the wire we are talking about, and as this is moving, as both the space shuttle and the satellite is moving in the outer space, we see that the Earth's magnetic field, which is shown by B Earth, acts on this moving conductor, and as we saw earlier, it will induce motional EMF in this conductor. And the motional EMF was known, or we had given the equation to be this, so we're just going to substitute for B is the Earth's magnetic field, known to be given here, and L is the length of the conductor, where the L is, this is L, 20 kilometer, this is B, field of the Earth, and then this is the velocity with which the conductor is moving in the outer space, and you can see a very large voltage getting induced. This produces a current in the conductor, and you can get the current also if you wanted. The current would be, you just take this EMF that you have and then divide by the resistance of the conductor, because the conductor should have a very small resistance, and then that will produce actually quite large current. So here we have a situation in which we produced current in this conductor just by moving it across through a region of Earth's magnetic field, and essentially this all happened because of the concept of motional EMF.